Voyager 1, humanity's pioneering explorer, has defied all expectations since its 1977 launch. Now, more than 4 decades into its journey beyond the heliosphere, it continues revealing hidden cosmic phenomena. Recent encounters in deep space have confirmed fears long held by scientists about the unknown dangers and mysteries lurking in interstellar space, fundamentally redefining our understanding of the universe and our place within it. The birth of a star sailor. Voyager 1 emerged from an era of unprecedented ambition and innovation, conceived during the 1970s as part of NASA's ambitious Voyager program designed to explore the outer solar system. Built by the Jet Propulsion Laboratory with project scientist Ed Stone overseeing the mission direction, Voyager 1 was equipped with an advanced suite of scientific instruments specifically designed to survive the harsh environment of deep space. Launched on September 5, 1977, it embarked on what would become humanity's most audacious journey into the cosmic unknown, destined to become the first human-made object to reach true interstellar space. The spacecraft carries humanity's hopes and dreams across the galaxy, immortalized in the included golden record containing sounds and images representing Earth's incredible diversity. This remarkable machine, weighing just 722 kilograms, would eventually travel farther from home than any other human creation, becoming our species' first ambassador to the stars and opening entirely new frontiers in space exploration that continue inspiring generations of scientists and dreamers worldwide. The Grand Tour. The Voyager mission represented an unprecedented grand tour of the outer planets, taking advantage of a rare planetary alignment that occurs only once every 175 years. Voyager 1's carefully planned trajectory included spectacular flybys of Jupiter in 1979 and Saturn in 1980, delivering breathtaking images and groundbreaking scientific data that completely transformed our understanding of planetary science. The spacecraft's discoveries included detailed observations of Jupiter's Great Red Spot, revealing its complex atmospheric dynamics, and unprecedented views of Saturn's intricate ring system that showed structures far more complex than anyone had imagined. Each planetary encounter expanded our knowledge of the solar system's architecture while using gravitational assist to propel the spacecraft toward its ultimate destination in interstellar space. Project scientist Edward Stone marveled at how the mission consistently surpassed all initial goals and expectations, providing discoveries that revolutionized multiple fields of astronomy. The Grand Tour established Voyager as one of the most successful space missions in human history, setting the stage for even more remarkable discoveries that would come decades later as it ventured into the unknown realm beyond our solar system. The Golden Record. Voyager 1 famously carries the Golden Record, an extraordinary phonograph disc containing sounds and images carefully selected to represent Earth's incredible diversity and humanity's greatest achievements. Conceived and overseen by a team led by renowned astronomer Carl Sagan, this remarkable time capsule includes greetings in 55 languages, music from various cultures spanning classical compositions to folk songs, and natural sounds from Earth's environment including whale songs, thunderstorms, and human heartbeats. The record serves as both humanity's ultimate time capsule and our most ambitious attempt at communication with potential extraterrestrial intelligence that might someday encounter the spacecraft drifting through interstellar space. The Golden Record's ingenious design included detailed instructions for decoding its contents, with diagrams showing how to construct a record player and locate Earth within the galaxy using pulsar map coordinates. Decades later, this golden disc has become an enduring symbol of human unity, curiosity, and our deep desire for connection across the vast cosmos, immortalizing our quest to reach beyond our planetary boundaries and establish meaningful contact with whatever intelligent life might exist among the stars. Years in the Void. For more than 4 decades, Voyager 1 has journeyed through the vast darkness of space, continuously transmitting invaluable scientific data as it passed beyond the asteroid belt and entered the outer reaches of our solar system. Despite traveling more than 150 astronomical units from the Sun, a distance so immense that radio signals now take over 22 hours to reach Earth, its sophisticated instruments continue functioning remarkably well, providing unique insights into space weather patterns, cosmic ray behavior, and the complex dynamics of solar-wind interactions. Mission operations at NASA's Jet Propulsion Laboratory have faced unprecedented challenges, including steadily weakening power levels, extreme communication delays, and the need to manage aging systems designed in the 1970s using modern computer technology. Engineers have performed miraculous feats of remote troubleshooting, developing innovative techniques to maintain spacecraft health across interstellar distances while conserving precious power resources. Voyager 1's extraordinary longevity represents a testament to both robust engineering design and humanity's persistent determination to explore frontiers far beyond our known boundaries, proving that human ingenuity can overcome seemingly impossible technical challenges. Crossing the boundary. In August 2012, Voyager 1 achieved a historic milestone by crossing the heliopause, the mysterious boundary where the sun's influence dramatically diminishes and true interstellar space begins. This unprecedented achievement represented humanity's first tentative step into the vast galactic environment beyond our solar system's protective bubble. Scientific instruments on board detected dramatic changes in plasma density, magnetic field strength, and cosmic ray intensity, providing definitive evidence that the spacecraft had entered an entirely new cosmic environment never before directly explored by human technology. The spacecraft's signals confirmed that solar wind particles had given way to the interstellar medium, a historic validation of decades-old theoretical models about the heliosphere's structure and behavior. Mission scientist Ed Stone heralded this discovery as a triumph of human exploration, marking humanity's transition from inhabitants of a single solar system to active explorers of the broader galactic neighborhood. Subsequent measurements have continued refining our understanding of this complex boundary region, revealing unexpected turbulence and magnetic field configurations that challenge existing models. This crossing established Voyager 1 as humanity's first true interstellar spacecraft, opening entirely new chapters in space exploration and cosmic discovery. Signals from nowhere. Voyager's sophisticated instruments have detected enigmatic radio signals emanating from regions far beyond our solar system, creating one of the most perplexing mysteries in modern astrophysics. These mysterious signals from nowhere exhibit unusual patterns and characteristics that remain inconsistent with any known natural sources or previously understood cosmic phenomena. Leading the investigation into these anomalous transmissions, astrophysicist Donald Gurnett and his research team continue analyzing whether these signals originate from interstellar plasma oscillations, unknown cosmic ray interactions, or potentially even more exotic phenomena that challenge current understanding of physics. Some researchers hypothesize that these signals might result from interactions with mysterious magnetic structures, unknown particle fields, or previously undiscovered processes operating within the interstellar medium itself. The phenomenon has forced scientists to reconsider existing astrophysical models and may point toward entirely new physics operating in the vast spaces between stars. These continuing discoveries affirm that our galaxy remains profoundly mysterious, harboring phenomena that extend far beyond current scientific comprehension and suggesting that interstellar space contains secrets that could revolutionize our understanding of cosmic processes and the fundamental nature of reality itself. The temperature mystery. Temperature measurements from Voyager 1 continue defying initial scientific expectations and creating new puzzles about the nature of interstellar space. Despite existing in the supposedly frigid environment beyond the heliosphere, instruments aboard the spacecraft have recorded unexpected temperature fluctuations and anomalously warm zones that challenge conventional models of interstellar medium behavior. Leading researcher Bill Kurth and his colleagues have analyzed extensive data suggesting complex thermal processes and unprecedented turbulence occurring in this mysterious boundary region between solar and galactic environments. These surprising findings significantly complicate existing models of interstellar medium properties, implying far more dynamic and complex interactions between particles, magnetic fields, and energy sources than previously theorized by astrophysicists. The temperature anomalies suggest active heating mechanisms that could involve magnetic field reconnection events, shockwave propagation, or entirely unknown physical processes operating on galactic scales. Understanding these thermal mysteries offers crucial insights about our sun's broader galactic environment and potential hazards that future spacecraft might encounter when venturing beyond our solar system. The discoveries underscore how much remains unknown about the cosmic environment surrounding our solar system, and the fundamental processes shaping interstellar space. Changing course. Voyager 1's trajectory has exhibited subtle but measurable course changes over time, creating new mysteries about forces operating in interstellar space. These deviations appear to result from complex gravitational influences and unexpected interactions with interstellar matter that weren't fully anticipated by mission planners. Analysts at NASA's Jet Propulsion Laboratory, including project scientist Suzanne Dodd, have carefully documented trajectory deviations that cannot be completely explained by existing models of solar gravitational effects alone. The observed course changes may arise from interstellar wind pressures, gravitational effects from unseen cosmic structures, or potentially even interactions with dark matter concentrations or gas clouds drifting through our local galactic neighborhood. Continuous tracking and sophisticated data analysis provide valuable insights that inform navigation strategies and propulsion requirements for future deep space missions venturing beyond the heliosphere. These findings highlight the remarkably dynamic nature of the galactic environment and demonstrate the critical need for adaptive mission designs capable of responding to unexpected conditions. The trajectory modifications reveal that interstellar space contains forces and influences that extend far beyond current scientific understanding, suggesting that future interstellar missions will face challenges that remain largely unknown and unpredictable. Ghost in the machine. The spacecraft's onboard systems occasionally exhibit unexplained glitches and anomalous behavior that has led some mission specialists to speculate about a metaphorical ghost in the machine affecting Voyager's operations. NASA engineers continuously address these technological anomalies through increasingly sophisticated remote troubleshooting techniques, working across impossible distances to maintain spacecraft functionality. Some hypothesized issues relate to cosmic radiation impacts, gradually affecting electronic components, while others may result from normal aging processes in hardware systems originally designed for much shorter operational lifespans. The mysterious nature of these intermittent glitches adds a distinctly human element to the otherwise mechanical journey of Voyager 1 through the cosmic void. Mission engineer Linda Spilker frequently remarks on the extraordinary challenges of operating technology that's now over 4 decades old, while maintaining functionality across interstellar distances that test the absolute limits of human engineering capabilities. These technical anomalies serve as constant reminders of the spacecraft's remarkable resilience and the incredible ingenuity of the engineering teams who continue supporting its mission. The glitches also highlight how little we understand about the long-term effects of interstellar environment exposure on sophisticated electronic systems, creating valuable lessons for future interstellar mission design. Patterns within patterns. Voyager 1's continuous stream of scientific data has revealed intricate nested patterns in cosmic rays, magnetic fields, and plasma waves that researchers have dubbed patterns within patterns, complex structures that hint at deeper organizational principles operating throughout interstellar space. Leading physicist Donald Gurnett uses these unprecedented observations to develop sophisticated computer models of the interstellar medium's complex structure, revealing organizational patterns that extend across vast scales throughout our local galactic neighborhood. These nested fluctuations and systematic variations hint at turbulent cascade processes and magnetic reconnection events that may be actively shaping the galaxy's environmental conditions over cosmic timescales. The continuous analysis and interpretation of such cosmic complexity underscores the virtually endless frontier that astrophysical research represents and humanity's enduring quest to understand our place within the broader universe. Each new data transmission from Voyager reveals additional layers of cosmic organization that challenge existing theoretical frameworks and demand new approaches to understanding galactic physics. The discoveries demonstrate that even the seemingly empty spaces between stars contain rich, dynamic structures that influence cosmic evolution processes. These patterns suggest that interstellar space operates according to fundamental physical principles that remain largely mysterious, despite decades of intensive scientific investigation and theoretical development. Voyager 1's impossible encounter with the mysteries of deep space has both confirmed our worst fears and revealed profound cosmic secrets that challenge everything we thought we knew. As humanity's first interstellar ambassador, it continues providing unprecedented insights into phenomena beyond our solar system. the spacecraft's remarkable journey highlights both human ingenuity and the vast mysteries awaiting discovery in the cosmos. Which of these revelations surprised you most? Share your thoughts below. If you found this cosmic journey fascinating, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more extraordinary discoveries from the final frontier. What if the most profound discovery in human history was made, and then deliberately buried? We're not talking about rumors or grainy photos here. We're talking about 24 gigabytes of classified NASA data on an interstellar visitor that, honestly, just defied the laws of physics. Data leaked by a ghost-like hacker group revealing a 26-kilometer-wide object that wasn't just passing through our solar system, but get this, actively navigating it. This is the story of 3I Atlas, what NASA allegedly found and why they never wanted you to see it. Let's delve into the data. Event Horizon cyber attack. How does a secret stay buried in the digital age? Well, sometimes it just doesn't. In the dead of night on September 2nd, 2025, a hacker collective calling themselves Event Horizon executed a flawless cyber attack on NASA. They didn't just knock on the door, they dismantled it. By exploiting a zero-day vulnerability in an outdated mission planning module, they bypassed layers of federal firewalls. Security logs, which were later leaked themselves, show a terrifying timeline. At 3:14 a.m. Eastern, initial access was gained. By 3:19 they had escalated their privileges to the highest level. At 3:23, the exfiltration began. In less than 7 minutes, 24 gigabytes of compressed files were siphoned from a secure server containing mission telemetry, internal communications, and top-secret analysis on Object 3Y Atlas. By 3:30 they were gone. The attackers left no signature, no digital fingerprints, only a silent void in the server logs where critical audit trails should have been. The specific target was a data archive tied to the Deep Space Network, containing the most sensitive raw telemetry. NASA's internal cyber forensics team was left with nothing but a clean exit, a ghost in the machine that had walked out with the crown jewels. The manifesto and distribution. A data breach is one thing, but a declaration of war on secrecy is another. Within hours of the hack, a manifesto from Event Horizon appeared on encrypted forums. Their message wasn't a boast, it was a justification. They claimed the breach was a direct response to what they termed unlawful cosmic secrecy, arguing that discoveries of this magnitude belong to humanity, not to a select few government agencies. The manifesto warned that the stolen files contained information so sensitive even senior directors at NASA were allegedly unaware of its full scope. Their language was direct: the world deserves to know what its own scientists have found. To prove their point, they began a strategic distribution campaign. Blurred screenshots and heavily redacted memos were sent to journalists and channels known for covering classified science. They specifically avoided mainstream outlets, opting for platforms that would analyze the data without an institutional filter. This drip feed of information created a groundswell of speculation that legacy media couldn't ignore, forcing the conversation into the open on Event Horizon's terms. Authenticating the documents. How can we be sure these leaks are real? The proof is in the details. The screenshots that flooded encrypted channels are layered with evidence of their origin. Documents are stamped confidential in bold block letters. Metadata tags show a 0314 UTC timestamp, matching the breach window from NASA's own security audit. A mission patch appears in the corner, a stylized comet streaking past a NASA vector, flanked by the code 3I Atlas int. One partially blurred memo lists the object's trajectory with terrifying numbers: hyperbolic V infinity of 26.1 kilometers per second, and an eccentricity, or E, of 6.2. These figures confirm an interstellar origin at a speed that, honestly, just defies simple explanation. Another screenshot shows a status log from the intercept team. Most text is blacked out except for a single phrase: plume anomaly flagged at T plus 11.3 seconds. The documents include FITS file headers for raw imaging data and internal routing codes for JPL's document management system. These are the kinds of mundane technical details that are nearly impossible to fake convincingly. Discovery of 3I Atlas. Before the leak, there was the discovery that started it all. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, or ATLAS survey in Hawaii, logged a new object tearing into the solar system at 130,000 miles per hour. Astronomers flagged it immediately. This was no ordinary comet. The object, soon labeled 3Y Atlas, measured an estimated 26 kilometers across, roughly the size of Manhattan, moving faster than any object ever observed inside the orbit of Jupiter. Veteran survey scientist Dr. Lina Takahashi, a fictional name from the leaked files, was quoted in a log. The track was so steep, the software flagged it as an error. Within hours, observatories from Chile to Arizona confirmed the numbers. The object's incoming speed of over 58 kilometers per second defied the sun's gravitational grip. Its trajectory pointed back toward the constellation Lyra, far from the ecliptic plane where most solar system debris resides. To put its size in perspective, the asteroid that killed the dinosaurs was only about 10 kilometers wide. This was over twice that, and it wasn't from around here. Impossible physics and trajectory. Here is where the data gets terrifying. The trajectory of 3I Atlas was not just interstellar, it was unnatural. Calculations from the Minor Planet Center confirmed by JPL revealed an orbital eccentricity of over 6. For context, most comets from our own Oort cloud barely reach an eccentricity of 1.0. Our first interstellar visitor, Oumuamua, had an eccentricity of 1.2. A value of 6.2 means the object was moving on an almost perfectly straight line at a velocity that gravity could barely alter. But the most damning piece of evidence detailed in the leaked mission logs was a sudden, unexplained sideways acceleration on July 18, 2025. It was a course correction. The object wasn't just flying, it was steering. The maneuver required a change in velocity, or delta V, that would have required gigatons of force to achieve on an object of this mass. All natural explanations, outgassing, solar radiation pressure, even a gravitational assist from an unknown planet, were systematically modeled and ruled out by JPL's top analysts. The physics simply didn't work unless the push came from within. Surface anomalies, the armor problem. What does a 26-kilometer object from another star system look like? The first leaked images from the Intercept mission were paradigm-shattering. 3I Atlas's surface resembled no comet on file. Imaging analysts flagged a pattern of smooth, almost metallic-looking plating, broken by lines that ran too straight to be natural fractures. One analyst, quoted in a redacted chat log, called it the radiator problem, referring to a gridwork of raised ridges spaced like the cooling fins on spacecraft. These ribs cast long, uniform shadows, and their regularity caused the anomaly detection software to flag the pattern as artificial. Comparisons to known comets like Halley or 67 P. Churyumov-Gerasimenko fell apart. Their surfaces are jagged and chaotic. 3I Atlas, in contrast, had long stretches that reflected sunlight like polished alloy. Further spectral analysis of this reflected light showed an albedo inconsistent with any known meteoritic iron, lacking the usual chondritic features. It was too smooth, too reflective, and far too structured. Thermal signatures and heat pulses. This is where the data points directly to active technology. Martin Cordner's team at Goddard Space Flight Center, a name appearing in the leak, got a full infrared spectrum of 3I Atlas. The data was so sensitive it was sealed within hours under a restricted embargo. The logs show the Webb telescope's infrared array recorded heat vents pulsing with the regularity of a clock every 90 seconds. Heat would pool along the radiator seams and then burst outward in tight, directed jets, not the broad, chaotic outgassing of a comet. The mission logs label this a directive motion event, a term usually reserved for spacecraft thrusters. More disturbing, trajectory analysts correlated these thermal pulses with the object's subtle course corrections. Each 90-second heat pulse matched a tiny, precise adjustment needed to maintain its hyperbolic escape route. The focused nature of these thermal events implies the existence of engineered nozzles or vents, as a natural body's heat would dissipate uniformly across its surface according to the laws of thermodynamics. This was controlled, focused, and undeniably artificial. Chemical composition mysteries. The mystery only deepens when you look at what 3I Atlas was made of. Martin Cordner's team at Goddard was the first to get a full spectrum after the Intercept, and the results were an instant red flag. The early spectra lit up with incredibly sharp, bright lines of nickel. In cosmic bodies, nickel almost always rides shotgun with iron. Yet in every single frame of data from 3I Atlas, iron was almost completely absent. Its signature spectral lines were missing. This isn't just rare. In the entire catalog of known comets and asteroids, it's unheard of. The natural formation processes that create asteroids from protoplanetary disks simply don't separate these two elements with such purity. Leaked notes suggest the isotopic ratio of the nickel was also wrong, indicating it wasn't formed in a typical supernova. The purity level was estimated to be over 99.8%, a level that on Earth requires an advanced electrochemical process known as the Mond process. Radio echoes and communication patterns. Did we ever try to listen? According to the leaked files, yes. And what we heard was terrifying. While public-facing projects might report silence, the classified logs from the Deep Space Network told a different story. Radio astronomers reviewing the intercept mission's raw data flagged a pattern that shouldn't have been there, faint repeating echoes bouncing back from the object at regular intervals. These were not natural radio bursts or cosmic static. They were precise, clipped signals echoing at intervals that mapped almost perfectly to the 90-second timing of the object's thermal pulses. A veteran telemetry specialist named Marissa Singh, in a chat log later leaked by Event Horizon, wrote, "It's like someone is pinging the probe and it's answering. The pattern is too tight for random noise." The return signal wasn't a simple reflection. It was modulated, carrying a complex phase shift. It was, for all intents and purposes, a reply. This suggested the object was not just passive, but an active system processing and responding to incoming stimuli. Expert analysis and propulsion theory. You can't discuss these anomalies without bringing in a voice of scientific courage like Avi Loeb. The Harvard astrophysicist, who famously staked his reputation on Oumuamua being alien technology, wasted no time weighing in on the 3I Atlas files. He argued the intercepted telemetry read like a blueprint for an advanced propulsion system. Each 90-second heat pulse and corresponding course correction was perfectly consistent with a massive ion drive or a similar engine. In Loeb's words, if you wanted to navigate through a solar system while managing heat and energy, you would use timed, directional thrust. That is what the data shows. But the most jarring evidence was a fragment recovered by the interceptor's dust collector. A leaked lab memo described a fleck of material with a lattice of silicon and doped phosphorus, arranged in layers spaced at micron intervals. The structure was noted as being radiation-hardened to a degree far beyond current human capability, suggesting it was built for long-duration travel through the harsh interstellar medium. This wasn't just a circuit, it was an artifact from a civilization far beyond our own. So, what does this all mean? We have a fictional but detailed account of an interstellar object, 3I Atlas, discovered in 2025, and we have a leaked cache of alleged NASA documents that point to a disturbing conclusion, that the object was a piece of technology. Metallic armor, rhythmic heat pulses that act as thrusters, refined nickel, and structured radio echoes all point to an artificial origin. The most shocking piece of evidence, a microscopic fragment that resembles a computer chip, pushes this story from science fiction into something far more unsettling. While the leak itself is part of this narrative, it forces us to ask a terrifying question. What if our first definitive contact isn't a message but a 26-kilometer machine flying silently past our window? The truth is still out there. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the secrets of science and technology. Thanks for watching Future Facts. 15 billion miles from Earth, NASA's ancient Voyager 1 spacecraft just detected something that shouldn't exist. 305 massive objects moving in perfect formation through the darkness of interstellar space. These aren't planets, asteroids, or comets. They're something else entirely, gliding through the void with deliberate precision that defies every law of physics we understand. The objects appeared to communicate with each other through rhythmic pulses, maintained impossible trajectories, and displayed behaviors that left NASA scientists questioning everything they thought they knew about the universe beyond our solar system. The Lonely Pioneer's shocking discovery. What if humanity's most distant explorer just stumbled upon proof that we're not alone in the universe? Voyager 1, launched in 1977 when Star Wars first hit theaters, has become something truly remarkable. The first human-made object to reach interstellar space, the region between stars where our sun's influence fades away. This car-sized spacecraft has traveled over 15 billion miles from Earth, so far that radio signals moving at light speed take 22 hours to reach it. When engineers send a command, they wait almost 2 full days for a response. The spacecraft carries instruments that seem ancient by today's standards: magnetometers, cosmic ray detectors, and plasma wave sensors designed with 1970s technology. What makes Voyager's survival incredible is that it wasn't built to last this long. Engineers expected it to function until maybe the early 2000s, yet here we are in 2025, and Voyager continues whispering back to us across the stars. Its nuclear power source, running on decaying plutonium, was supposed to have died decades ago. The spacecraft also carries the famous Golden Record, a time capsule of Earth sounds, music, and greetings meant as a message to any intelligence that might find it. Little did we know this cosmic hello might have already attracted attention much sooner than anyone expected. The first anomalous signal. In the endless stream of data flowing back from Voyager, something appeared that would change everything. A tiny flicker that seemed like nothing at first. Space is full of dust and radiation, and occasional weird readings are normal, so NASA's Jet Propulsion Laboratory initially dismissed it as background noise. Suzanne Susie Dodd, one of the mission specialists who first noticed the anomaly, described it as like shouting into a canyon for decades and finally something shouts back. The reading was faint, just a slight reflection of light picked up by Voyager's sensors that seemed too minor to investigate further. But then something changed. This wasn't just a particle floating randomly through space. The object moved in a way that caught everyone's attention. It curved, accelerated, and didn't tumble chaotically like debris would. Instead, it glided smoothly, as if under intelligent control. When Voyager's plasma sensors registered a shift that seemed deliberate and focused, the team realized this wasn't background noise. Jonathan D.A. Clark observed that the object's movement was unlike anything natural, describing it as the kind of deliberate motion one might expect from a drone rather than a rock, suggesting it had intention. That observation changed everything, because in the physics of space, things don't just move with purpose unless something is making them move that way. Ruling out natural explanations. When something unusual appears in space, scientists have a standard playbook. They systematically check all familiar possibilities. Is it a small moon, distant comet, or new asteroid? One by one, the team worked through these options, and one by one, each possibility fell away. This object wasn't a planet, far too small. Not a comet either. There was no tail, no ice trail, no heat signature. It didn't glow like a star, and gravitational lensing couldn't explain what they were seeing. Even space dust was ruled out because dust doesn't suddenly change direction mid-flight. Dr. Nicola Fox at the Jet Propulsion Laboratory ran simulation after simulation, trying to match the object's behavior to known models. What makes space objects usually predictable is physics. Everything moves according to known patterns and forces. But this object broke those rules. Its path bent in ways that didn't match any known orbital behavior, with no drift or decay expected from natural objects. The team was forced to admit something difficult. What they were seeing wasn't just unknown, it was unnatural. The movement pattern suggested intelligence, or at least design. The object seemed to be moving with purpose on a specific trajectory that couldn't be explained by gravity, solar wind, or any other forces that typically influence objects in space. It was as if something was guiding it, adjusting its course with precision. Confirmation from Voyager 2. Just as scientists were trying to make sense of what Voyager 1 had detected, something extraordinary happened that transformed this curious anomaly into something far more significant. Voyager 2, the twin spacecraft following a completely different path millions of miles away, detected something eerily similar. The same kind of magnetic fluctuation, the same kind of pulse, a matching signal signature that changed everything. This was the turning point in the investigation. Two different probes, two separate instruments picking up nearly identical phenomena ruled out the possibility of internal error. It wasn't a software glitch or sensor malfunction on Voyager 1. Whatever this was, it was real and happening in multiple directions of space. ESA analyst Mark Fontaine compared it to two lighthouses both catching a flash of something passing between them. This cross-confirmation gave the anomaly weight and credibility. It wasn't noise. It wasn't Voyager acting up. It was a real, coordinated phenomenon happening in the space between stars. The team now had evidence that couldn't be dismissed. Something was moving through the region where both Voyagers were traveling. With this confirmation, NASA quietly triggered what's known as a Level 3 alert, a designation used only for phenomena that don't fit within our current scientific understanding. The event was real, the math was consistent, the movement appeared deliberate, and nobody knew what to make of it.
The formation of 305 objects.
When the team analyzed the full telemetry logs, what they discovered sent chills down their spines. This wasn't just one or two anomalies moving through space, there were 305 objects, all moving together in formation. Each one glided past Voyager 1 in what appeared to be a choreographed arc, smooth, precise, and coordinated. These weren't debris fragments scattered randomly. There was no heat signature, no tails, no signs of decay you'd expect from natural objects. Most striking of all, the reading showed rhythmic pulses echoing through the plasma waves, the kind of pattern you'd expect from something engineered, not formed by chance. The 305 objects weren't simply passing through randomly. They were moving together as a unit, maintaining relative positions to each other in a way that suggested organization and purpose. In space, groups of objects tend to spread out over time due to slight differences in velocity and gravitational influences. Yet these objects maintained their positions relative to each other with precision that seemed impossible without some form of control or guidance. Some scientists compared it to watching a flock of birds or school of fish, except these were in the vacuum of space where such coordinated movement shouldn't be possible without technology. What made this discovery particularly unsettling was the scale. 305 objects all moving with the same unnatural characteristics, all passing by Voyager at roughly the same time suggested something far more significant was happening in interstellar space.
The language of rhythmic pulses.
As scientists examined the data more closely, something truly strange appeared in the signals. Patterns of repetition that weren't the kind you'd expect from stars or cosmic background radiation, but steady, measured sequences that suggested communication or control systems. The plasma wave pulses coming from these 305 objects had loops, sequences, and structures that hinted at something more complex than random cosmic noise. They didn't just pass by Voyager, they seemed to broadcast signals as if they were pinging, scanning, or talking to each other. Dr. Serena Patel from Caltech observed that the patterns felt less like nature and more like a language or a system. The idea was shocking, but increasingly difficult to ignore. These objects weren't moving in a chaotic swarm, but in an ordered, intentional formation similar to how programmed drones might operate. Some experts went further in their assessment. ESA's Eric Lousy suggested this could be some sort of probe network, though he was quickly asked to stop speculating publicly. Even typically, grounded scientists like Neil deGrasse Tyson admitted there were patterns in that data that aren't random. To be absolutely certain they weren't seeing a glitch, the team activated one of Voyager's oldest subsystems, a backup telemetry channel that hadn't been used since the 1990s. The backup system confirmed everything the primary systems had detected. The signals, the paths, the formations, all identical readings sent through a completely different channel. The implications were staggering.
Impossible propulsion systems.
Voyager's readings didn't just capture the presence of the objects, they revealed how these mysterious entities moved through space, and this is where things got even stranger. There were no engine flares, no ion trails, no signs of any propulsion system we would recognize, yet Doppler shift measurements showed these objects accelerating rapidly, smoothly, and directionally. Some were moving faster than anything humans have ever launched. According to the data, some speeds even exceeded the calculated escape velocity of the entire Milky Way galaxy. These weren't objects drifting passively through space. They were powered somehow, moving with purpose and incredible speed. Dr. Eric J. Zernstein from Princeton noted that they're not floating through space, they're navigating it. But what worried him more was their path. These objects didn't come near Earth or show any interest in our solar system. They passed by at a calculated distance as if deliberately avoiding us or simply had no reason to stop. The method of propulsion remained a complete mystery. Nothing in our current technology even comes close to explaining how these objects move. They appeared to be manipulating space itself, creating waves or ripples in the fabric of space-time that allowed them to glide forward without conventional thrust. Theoretical physicist Elena Reyes described it as, not flight as we understand it, but more like gliding on something we don't yet know how to measure, as if these objects were using the medium of space itself to move.
Earth detects the echoes.
While NASA focused on Voyager's raw data, something odd started happening back on Earth that would make this mystery even more compelling. Across various corners of the globe, amateur radio operators, some just hobbyists with backyard setups, began reporting strange activity. They were picking up weak, irregular pulses, a kind of rhythmic static that didn't match any known terrestrial source. At first, it seemed unrelated, just coincidence. After all, radio interference happens all the time. But then the reports were time-stamped and compared. They aligned almost perfectly with the same hours that Voyager had recorded its most intense plasma anomalies. These weren't professional observatories or part of any official deep space listening effort. Most of these setups were built from spare parts, tuned to catch meteor scatter, amateur satellites, or solar flare chatter. Yet somehow they were detecting faint echoes of what Voyager had picked up billions of miles away. The signals weren't strong, but they had pattern and regularity, like ripples reflecting off invisible walls in the ionosphere. This raised a troubling question. Was this bleed-through accidental, or was it purposeful? Was something out there testing Earth's listening capability, dropping breadcrumbs for us to follow? That uncertainty kicked off a quiet storm behind the scenes. NASA began encrypting parts of its deep space telemetry feeds, and intelligence agencies took notice, beginning discussions about electromagnetic security and whether these signals could be weaponized or intercepted. The machine awakens. Then, as if things weren't strange enough, Voyager itself started acting differently in ways that defied explanation. Its guidance system, called the AACS, Attitude and Articulation Control System, began misbehaving, not catastrophically like a crash. But it started routing data through old, long unused systems, almost like it was bypassing its own core software. At first, engineers thought it was a bug. After all, this is a 47-year-old spacecraft running on code older than most people analyzing it. But the deeper they looked, the weirder it got. Voyager wasn't failing. It was reconfiguring itself, reactivating memory segments that hadn't been touched in decades, rerouting its telemetry in ways that were never programmed. Then came the kicker. This behavior began right after one of the magnetic pulses from the passing objects. Could that burst have flipped a bit of memory? Could it have triggered some dormant function buried deep inside Voyager's ancient architecture? What engineers found was both promising and terrifying. The machine was stable, the instruments were fine, but the new behaviors weren't going away. Whatever was causing them, it wasn't internal decay or software corruption. Voyager had touched something, or something had touched Voyager, and the spacecraft was different now. To understand what was happening, engineers had to dig deep, literally opening dusty file cabinets at NASA's Jet Propulsion Lab. Most of Voyager's software was written in early assembly language, with some instructions existing only as notes in 1970s paper manuals. Part of something bigger. As scientists continued analyzing the strange signals pulsing through Voyager's instruments, a new and even more extraordinary idea began to take shape. Among the plasma wave readings, certain patterns stood out. Pulses that didn't behave like natural energy bursts but looked structured, measured, and intentional. Then someone noticed something else. The waveforms resembled quantum oscillations used in modern quantum entanglement experiments. These are the same kinds of signals researchers use on Earth to transmit information between particles separated by distance. It was subtle but undeniable, opening the door to a possibility no one had considered before. What if Voyager wasn't just recording random events in deep space? What if it had become part of something bigger? Maybe the 305 objects weren't just flying by. Maybe they were transmitting, broadcasting data through the interstellar medium using methods we don't yet understand. By pure chance, or maybe by design, Voyager was in the right place at the right time, with the right kind of analog sensors to pick it up. The signals didn't behave like random noise. They repeated, they looped, they followed harmonic intervals that looked eerily close to what you'd expect from encoded information. Something deliberately packed with meaning. Voyager, being such an old machine, might actually be the perfect listener. Modern probes are too noisy, filled with high-frequency electronics constantly transmitting and receiving chatter. But Voyager is slow, quiet, and analog. It has no clutter, no broadband digital static. It is, in a sense, the perfect ear in a cosmic concert hall, and being far outside the solar system, it's free from Earth's electromagnetic interference, just out there in the dark, listening like a perfect cosmic microphone. The mystery of Voyager's impossible encounter with 305 coordinated objects challenges everything we thought we knew about the emptiness of space. Whether these entities represent advanced technology from an unknown civilization, or natural phenomena operating by rules we haven't discovered, one thing is certain: the universe is far stranger and more populated than we ever imagined. As Voyager continues its eternal journey through the cosmos, it carries with it the possibility that humanity has just received its first glimpse of intelligence beyond Earth. What do you think these mysterious objects really are? Share your thoughts below, hit that like button, and subscribe to Future Facts for more mind-bending space discoveries. Until next time, keep looking up. What if NASA's live feed captured a glimpse of an alien probe, only to cut out at the exact moment it came into view? On June 18th, a single, baffling frame from the feed tracking our third interstellar visitor, 3I Atlas, showed something that looked unnervingly artificial. Then the screen went black. The official story is a network glitch, but the data, verified by citizen archivists worldwide, is real. So what was that razor-sharp edge glinting in the dark? Let's explore this together. The initial discovery. It all starts with a new traveler in our cosmic neighborhood. But this was no ordinary visitor. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, or ATLAS, a NASA-funded project led by principal investigator Larry Deneau at the University of Hawaii, flagged a new object. This system is our planet's frontline defense, a set of robotic telescopes scanning the entire sky every 24 hours to find asteroids on a collision course with Earth. But this object was different. Its trajectory was hyperbolic, meaning its velocity was so high it was clearly not bound by the sun's gravity. It was a perfect arc, slingshotting through our solar system on a one-way trip back to the interstellar void. Astronomers globally scrambled to confirm, and within 24 hours, the Minor Planet Center designated it 3Y Atlas, cementing its status as only the third confirmed interstellar object ever detected. The first images revealed the classic fuzzy coma and faint tail of a comet, but its speed and path told a different story. This wasn't one of ours. It was an emissary from deep space, a priceless opportunity for science. The discovery itself was a massive win, a testament to how far our detection capabilities have come since the first interstellar object, Oumuamua, nearly slipped past us unnoticed in 2017. The anomalous frame. Here's where a routine observation becomes a global mystery. The last recorded frame from NASA's feed, time-stamped at 03/17/12 UTC, appears normal at first. You see the dim nucleus of 3I Atlas, its hazy coma, and the faint tail streaking against the black. But then, in the lower left quadrant, something catches the light. It's a glint, but not a soft, natural one. It's a perfectly straight edge, not a curve, not an arc, but a sharp, geometric line. This is what physicists call specular reflection. Light bouncing off a smooth surface at a definite angle, like light off a mirror. This is in stark contrast to the diffuse reflection from a rough surface like a typical comet, which scatters light in all directions. Independent astronomers, spurred on by the kinds of questions that Harvard researcher Avi Loeb has been asking with his Galileo project about potential technosignatures, ran edge detection algorithms that flagged the anomaly within hours. The software highlighted a line segment measuring roughly 37 pixels, reflecting sunlight at an angle that defied easy explanation. Comet dust scatters light in chaotic, soft ways. This was different. The light bounced cleanly, as if from polished metal, not fractured ice or rock. It was a detail so out of place that it immediately raised an unsettling question. Was this natural, or was it engineered? Data verification. Before anyone could cry cover-up, the question of authenticity had to be settled. Was the image even real? This is where the story takes a fascinating turn, thanks to a global network of citizen archivists. These individuals run automated scripts that constantly monitor and download raw public data feeds from space agencies. Within minutes of the blackout, independent archivists in Australia, Germany, and the United States had already uploaded their captured data packets to public repositories. Each file, stamped with the same 03/17/12 UTC timestamp, was secured with a unique SHA-256 checksum. Think of this as a long, unforgeable digital fingerprint for the file. If even a single bit of data were changed, the fingerprint would be completely different. When compared, every single copy matched, bit for bit. The Australian archive's hash matched the German university's mirror and the original NASA relay. There was no evidence of tampering or digital manipulation. This airtight chain of custody proved that the anomalous frame was not a hoax. The data is real, the archive is clean, and the mystery, as the great astronomer and science communicator Carl Sagan would say, is worthy of investigation precisely because the evidence is preserved and verifiable by anyone with an internet connection. Technical explanations. So, if the data is real, could the blackout just be a perfectly timed coincidence? Here's what matters. NASA's live feeds are, well, incredibly complex. They rely on the Deep Space Network, which is this global system of massive radio antennas in Goldstone, California, Madrid, Spain, and Canberra, Australia, all working together to keep constant contact with spacecraft. This network, along with the tracking and data relay satellite system that was first launched way back in 1983, bounces signals from deep space back down to Earth. Dropouts, honestly, are not uncommon. Because the Earth rotates, a probe will eventually set below the horizon for one ground station, and the signal has to be handed off to the next station in the sequence. Sometimes this handover isn't seamless, and you get a brief interruption, what engineers call a handover blank. These usually show up as a 2-second gray screen. Each entry in the Deep Space Network logs, overseen by managers like JPL's Bradford Arnold, almost always provides a reason code like packet loss or relay outage. But the blackout at 0317 UTC, right at the exact moment the anomaly appeared, didn't fit the typical pattern. The public logs showed a gap without the standard explanatory code for a routine handover, making the timing deeply suspicious to many observers. Digital forensics. Let's zoom in on the pixels, because that's where, honestly, the technical debate gets pretty intense. Digital forensics teams immediately analyzed the last frame, and they found two key clues that could offer a mundane explanation. First, the sharp edge of the glint ran perfectly parallel to the borders of several 8x8 pixel blocks. That's a potential fingerprint of the MPEG video compression algorithm. To save bandwidth, these codecs slice frames into a grid, and can sometimes exaggerate or sharpen faint lines, snapping them into these unnaturally straight, blocky outlines. The second clue points to cosmic rays. Space is just filled with high-energy particles that can strike a camera's sensor, leaving a bright white streak that only lasts for a single frame. Digital image experts and university professors like Hani Farid have shown how these single-frame artifacts are actually pretty common in space photography. So one theory is a double hit. A fleeting cosmic ray created a faint streak that was then amplified and sharpened by the video compression, resulting in an illusion of a perfect edge. This provides a plausible, purely technical explanation, but it doesn't entirely close the case since the consistency and brightness of the glint were still considered unusual, even for a compression artifact. 3i Atlas background. To understand the anomaly, you have to understand the object itself. 3i Atlas was already a cosmic outlier before the mysterious frame even appeared. Spectroscopic analysis from the James Webb Space Telescope, detailed in papers by researchers like Martin Cordner at NASA's Goddard Space Flight Center, revealed that it was unusually rich in carbon dioxide. Most comets from our own solar system's Oort cloud, like the famous comet Hale-Bopp seen back in 1997, are primarily driven by water ice sublimating into gas. But 3i Atlas had a carbon dioxide to water ratio of nearly 8:1. This means CO2 was the main engine driving its outgassing and creating its massive coma, which stretched for hundreds of thousands of kilometers. This dense cloud of dust completely obscured the nucleus, making its exact size difficult to pin down, though estimates placed it at under a kilometer in diameter, similar to our second interstellar visitor, 2I Borisov, which was studied in 2019. The Atlas survey's ability to scan the entire sky quickly allowed astronomers to catch it early, providing a rare chance to watch an interstellar comet wake up. This unique chemical makeup already marked it as fundamentally different, a clue that it likely formed in a very different kind of star system than our own. Scientific scrutiny. In science, especially when claims are this extraordinary, the burden of proof is immense. The process of verification is honestly a gauntlet of scrutiny. An anomaly seen in a single frame by a single instrument is just the first step. This principle, that extraordinary claims require extraordinary evidence, is a cornerstone of the scientific method. If one observatory reports a geometric glint, others need to see the same thing, ideally across multiple wavelengths of light, to determine its material composition. Only then does the peer review process even begin. At every stage, scientists are trained to ask, is this a real signal, or is it an artifact? For 3I Atlas, the evidence so far sits on the lowest rung of this ladder. We have one intriguing frame, but no multi-instrument confirmation. Until the Hubble, Webb, or major ground-based scopes produce matching data, most researchers, including veteran SETI Institute astronomer Jill Tarter, would advocate for caution and continued observation, not immediate conclusions. It's a slow, methodical process designed to filter out wishful thinking and avoid the pitfalls of past astronomical misinterpretations, like Percival Lowell's infamous belief in the canals of Mars in the late 1800s. 3 theories. The debate has now fractured into 3 distinct paths. The first is rooted in known physics. Comets are violent, dynamic objects. As 3I Atlas neared the Sun, intense heat could have caused thermal fractures, splitting off a shard of rock or ice. Jets of carbon dioxide erupting from the surface can create torque, making the nucleus spin faster and faster until pieces break off. The glint could simply be sunlight catching the fresh, flat, crystalline face of a newly broken fragment. The second path points to a technical illusion. This is the Occam's razor answer, arguing that the edge is nothing more than a perfect storm, a chance alignment of a cosmic ray, digital compression artifacts, and background noise that tricked our eyes into seeing order in chaos. But the third idea, the one that captures the imagination, persists. This theory, in the vein of speculative ideas from physicists like the late Freeman Dyson, proposes that the edge is exactly what it looks like, something manufactured. A piece of a self-replicating von Neumann probe, a solar sail, or a protective shell designed to withstand interstellar travel. If true, it would mean we're looking at a message or a machine, not a comet. The odds are, honestly, astronomical, but the possibility lingers. Broader implications. An event like this, a potential signal followed by a sudden blackout, ripples far beyond astronomy labs. It triggers a profound shift in public consciousness and even scientific policy. The central question expands from what is that object to who controls the narrative of discovery. It fuels calls for greater transparency, with organizations like the Vera C. Rubin Observatory in Chile being designed specifically to capture and share vast amounts of data openly. For those of us watching, it becomes a powerful test of critical thinking, echoing the public's reaction to the famous 1977 WOW signal. That was a powerful 72-second radio burst detected by astronomer Jerry Amon that remains unexplained to this day. How do you separate a genuine mystery from a technical glitch or a cover-up conspiracy? The timing of the feed cut forces a conversation about our readiness for a potential discovery of this magnitude and whether international protocols like those discussed at the UN's Committee on the Peaceful Uses of Outer Space are sufficient. It blurs the line between healthy skepticism and profound wonder. If a single ambiguous frame can change how we search the skies, what happens when the next visitor leaves no room for doubt? The search continues. So, where does this leave us? The official record states that at 3:17 UTC, the NASA feed for 3I Atlas was interrupted. The final frame contained a geometric glint whose integrity has been verified. The feed drop has been attributed to routine network behavior, yet its timing remains an unnerving coincidence. As of today, there is no conclusive, peer-reviewed evidence to support an artificial origin. But the search is far from over. Missions are already being planned, like the European Space Agency's Comet Interceptor, slated for launch around 2029. It is a brilliant mission designed to lie in wait at a stable Lagrange point in space, ready to travel to a pristine, long-period comet or even a future interstellar visitor for a close-up look. This proactive approach, championed by scientists like the mission's lead, Geraint Jones, shows how seriously the scientific community is taking these objects. Every new interstellar visitor is a gift, pushing our technology, our curiosity, and our standards of proof forward. And maybe, just maybe, the next one will provide the answer we're all waiting for. The case of 3I Atlas remains a tantalizing puzzle, perfectly balanced between a mundane technical glitch and a discovery that could redefine humanity's place in the cosmos. The data is real, the anomaly is recorded, but the final explanation is still waiting out there in the dark. What do you think? Was this a ghost in the machine, a natural cosmic coincidence, or our first fleeting glimpse of technology from another star? Let us know your theory in the comments below. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our universe. Thanks for watching Future Facts.